Sometimes you look at people and wonder why some seem to just naturally excel on tests, while others who are clearly sharp in their own way might struggle.
Yeah, it's something you notice.
And it gets even more interesting when you see someone whose intelligence scores don't quite match up with their academic achievements.
Yeah.
These aren't just like water cooler questions,
And
right? For you, navigating education today, these standardized tests have a huge impact. So what's really going on beneath the surface?
those are the exact questions that drive a lot of research in this area. The fact that we see these discrepancies tells us that both intelligence and achievement are complex, and understanding the factors behind individual differences is, well, key.
Absolutely. And that's precisely what we're diving into today for you. We're going to unpack some really fascinating work from Stephen Pittrell and Bessie Wilkerson, their 2000 paper, Intelligence and Achievement, a behavioral genetic perspective, really digs into the heart of these whys. Now, our goal isn't to drown you in scientific jargon, but to explore, from the perspective of behavioral genetics, how much of intelligence and academic success comes down to our inherent nature versus the world around us.
Exactly. Petrel and Wilkerson provide a really insightful framework for understanding not just the genetic and environmental influences on intelligence and achievement separately, but perhaps more importantly for you, how they relate to each other and contribute to the variety of outcomes we see.
And by the end of this deep dive, we're confident you'll have some genuinely surprising insights about where intelligence and achievement come from, and maybe even a completely new way for you to think about them. So to get us started, let's make sure we're speaking the same language.
Good idea.
When this kind of research talks about intelligence and achievement, what specific things are they actually measuring?
That's a great place to begin to orient you. In behavioral genetics studies, intelligence is often assessed using standardized tests that evolved from the early Binet-Simon scales. Think of tests like the Stanford Binet or the Wechsler scales. Now, these aren't meant to capture every single aspect of what you might consider intelligence in everyday life, but rather they focus on specific cognitive abilities.
Things like your verbal skills, your ability to visualize things in your mind, that's spatial reasoning, right?
Right.
Plus, how quickly you can process information in your memory. And the idea is that even though these are different skills, they tend to be related, leading to this broader idea of general intelligence, often called G.
Precisely. While G doesn't explain every nuance of someone's cognitive strengths and weaknesses, it does account for a significant portion of the differences we see across those more specific abilities.
Ah.
And importantly for you to know, even with their limitations, these standardized intelligence tests have proven to be quite good at predicting things like future academic performance, how far someone might go in their education, and even their eventual career path.
Okay, that gives us a clearer picture of intelligence in this context. Now, when it comes to academic achievement for you, what kind of measures are typically used in these studies? Is it just about getting good grades?
Not exclusively, no. Standardized achievement tests are frequently used the kinds of tests designed to measure specific knowledge in areas like reading comprehension or math skill.
Right, like the SAPs or state tests?
Exactly. However, the researchers also acknowledge, and this is important for you to consider, that some argue these achievement tests can overlap quite a bit with intelligence measures.
Makes sense.
So you'll also see studies that use things like a teacher's overall evaluation of a student or their general grade point average, their GPA, as indicators of academic achievement.
All right, so we have a sense of how intelligence and achievement are being looked at in this research. Now, we get to the question that's probably on everyone's mind, including yours, nature versus nurture. But right off the bat, the paper emphasizes that this isn't an either-or situation, is it?
Absolutely not. That's a really outdated way for you to think about it. Behavioral genetics starts with the understanding that the differences we see in traits, whether it's intelligence or how well someone does in school, are a result of both the genes they inherit and the environments they experience. Okay.
The real question, and what's most insightful for you, is figuring out how much each of those contributes, and even more interestingly, how they interact.
Okay, so let's unpack some of the core concepts they introduce that help us understand these influences for you. First up is heritability. What exactly does that tell us about where our abilities come from?
Okay, so heritability, often shown as ACE on Iover, is a statistical measure. It tells you the proportion of the variation you see in a particular trait within a group of people that can be attributed to the genetic differences among them.
Within a group. Okay.
Now, the key thing for you to remember here is within a population. So if we say something like reading ability has a certain heritability, it means that a certain percentage of the differences in reading skills we observe in a group can be linked to the different reading-related genes those individuals have.
Right.
Think of it like this. If you notice that some families seem to have a real knack for reading, that might be partly because they share genes that make learning to read a bit easier. Got it. So it's about explaining why some people in a group are different from others in that trait, not saying that genes are the only thing that determines that trait in an individual.
Exactly right.
Now, what about the environment's role for you? They break that down into shared and non-shared. What's the difference there?
Right. So shared environment, represented as C in A, refers to all the environmental influences that tend to make family members more alike.
Like the same house, same parents?
Yeah, things like growing up in the same house, going to the same schools, having the same teachers. Those are all factors that siblings in a family typically share. Going back to our reading example for you, if brothers and sisters all grew up in a home with lots of books and were read to often, that shared environment could help explain why their reading abilities might be similar.
Okay. And then there's non-shared environment needs. This sounds like the experiences that are unique to each person within a family, right?
Exactly. Non-shared environment, ENI, captures all the environmental factors that contribute to making family members different from each other.
Oh,
This could be anything from having different circles of friends, participating in different after-school activities, even being treated differently by parents or having a unique relationship with a specific teacher.
like different hobbies or something.
Sure. In our reading example for you, maybe one sibling developed a real passion for fantasy novels and spent hours reading on their own, while the other preferred playing sports. Those individual experiences would fall under the non-shared environment. This category also includes any imperfections in how we measure these things, measurement error.
So for you to understand this, behavioral geneticists use these concepts, heritability, shared environment, and non-shared environment, to try and separate out how much of our intelligence and achievement comes from our genes, the environment we share with our families, and our own unique experiences. And they use those twin and adoption studies to help figure this out, right?
Precisely. By comparing identical twins who share all their genes to fraternal twins who share only about half, or by looking at how adopted children resemble their biological versus their adoptive families. Well, researchers can use statistical methods to estimate the relative contributions of these genetic and environmental factors for you.
Okay, so with those definitions in mind for you, let's dive into what the research actually reveals about the genetic influence on intelligence. What are some of the key things you should know?
Well, one of the most consistent and robust findings across a vast number of studies is that genetic factors play a statistically significant role in intelligence.
Okay.
The average heritability is around 50% when you look at the overall picture from twin and adoption research.
That's a pretty significant chunk for you to consider. So roughly half of the differences we see in intelligence within the population can be attributed to genetic factors.
It is, but here's where it gets really interesting for you. This isn't a fixed percentage throughout life. The heritability of intelligence actually seems to increase as we age.
Really? Increase.
Yeah, it starts lower, around 40% in early childhood, then rises to about 60% in early adulthood, and some studies even suggest it might reach as high as 80% in later life. Although there's some evidence of a possible slight decrease in very old age.
Wow, that's fascinating for you to think about. So as we go through life, our genetic predispositions seem to play an even more dominant role in our intelligence levels. Why might that be happening?
Well, there are a few potential explanations for you to consider. One idea is that as we get older, we have more freedom to choose environments that align with our inherent talents and interests.
Oh, okay.
This relates to the concept of gene-environment correlation we'll discuss later. Also, the small, cumulative effects of our genetic differences might just become more noticeable over time.
Makes sense.
Interestingly, as the influence of genes on intelligence appears to grow, the influence of the shared family environment tends to decrease, becoming quite small by adolescence and early adulthood.
So the family impact fades a bit.
In terms of making siblings similar for intelligence, yes.
Yeah.
And the non-shared environment, those unique experiences you have, remains a significant factor throughout your life.
Okay. And these trends, the increasing heritability with age and the changing roles of shared and non-shared environment, do these apply just to overall intelligence? Or do they also hold true for those more specific cognitive abilities, like verbal fluency, spatial reasoning, and processing speed for you?
The research suggests similar patterns for those more specific cognitive abilities as well.
Yes.
Okay, so that paints a picture of the genetic side of intelligence for you. Now, what does the research tell us about the genetic influence on how well we do academically? Are the patterns similar for you?
That's a really insightful question for you. While there haven't been quite as many studies specifically focused on the heritability of academic achievement compared to intelligence, the findings are quite compelling.
Oh,
Interestingly, the heritability of academic achievement turns out to be surprisingly high, almost on par with intelligence. And yes, we do see similar age-related trends emerging for you here as well.
So, just like with intelligence, the influence of our genes on how well we perform in school seems to become more pronounced as we get older for you.
That seems to be the general pattern. However, in the early school years in elementary school, the picture looks a bit different for you.
How so?
Studies suggest that the shared environment, things like the quality of the schools you attend and the home environment, appears to account for a larger portion of the differences in standardized test scores in reading, spelling, and math, perhaps around 60%.
60%. Wow.
Yeah. Genetic influences at this stage are estimated to be somewhat lower, around 30%.
That makes intuitive sense for you, right? When kids are very young, they're all largely in quite similar educational settings. The school has a big impact.
Exactly. But as children progress through their schooling, the balance shifts for you. The influence of genetics on academic achievement tends to increase, while the impact of the shared environment decreases. Research looking at things like report card grades in teenagers, performance on college entrance exams, and even the highest level of education attained in adulthood shows increasing heritability estimates and a diminishing role for those shared environmental factors for you.
That's really fascinating for you to consider.
Yeah.
So by the time we reach adulthood, our genes seem to play a pretty significant role in both our intellectual abilities and how far we go in our education.
Use that way.
Now, the paper also delves into the relationship between intelligence and achievement for you. We all kind of assume they're connected, but what does the behavioral genetics perspective tell us about that link?
You're right. There's a substantial and consistent positive correlation between intelligence and achievement, typically around 0.5
Okay,
grades.
so moderately strong.
And the researchers point out for you that this is likely a two-way street. Your intelligence can certainly influence how well you achieve academically, but your educational experiences and academic success can also have an impact on your measured intelligence.
So it's not just one thing leading to the other for you. It feeds back.
Exactly.
But how much of this connection is due to the genes we share, the environments we share, or a combination of both? The paper lays out a few different ideas, right?
It does. They discuss three main possibilities for you. The environment-only idea suggests that intelligence and achievement are linked because they are both shaped by overlapping environmental factors, like the quality of your schooling.
Plausible.
The gene plus environment hypothesis proposes that the correlation arises from a combination of shared genetic influences and overlapping environmental effects.
Also makes sense.
And finally, the gene-only hypothesis argues that the primary reason they tend to go together is because of shared genetic factors.
Okay, and based on the research for you, which of these explanations seems to hold up the best?
Well, interestingly, the gene-only model appears to be the most consistently supported across the lifespan for you.
Really? Mostly genes.
It seems so. While both intelligence and achievement are definitely influenced by both your genes and your environment, the reason they tend to be correlated seems to be largely due to the same underlying genetic factors influencing both.
Wow.
So a real aha moment here for you is that while we often think of environment as the bridge between intellect and success, this research suggests the link runs deeper, often starting with our shared genetic code.
So for you, the same genes that contribute to, say, strong verbal reasoning skills might also make it easier to excel in subjects that heavily rely on those skills, like reading comprehension.
That's the core idea. Now, it's crucial for you to remember that a correlation of 0.50 means that a significant portion of the variation in achievement, about 75%, is not shared with IQ.
Oh, right. That's important.
Very important. So your environment and also some genes that are specific to either intelligence or achievement play a big role in why your academic performance might differ from what you'd predict based solely on your intelligence test scores. And the researchers highlight that this discrepancy between an individual's intelligence and achievement scores is largely driven by those unique, non-shared environmental experiences you have, along with some independent genetic influences on each trait.
They even mentioned some specific studies that support this for you, right? Like that study with twins who are younger and the one looking at adopted children.
Yes. The 1991 study by Thompson, Detterman, and Plowman, which looked at twins between the ages of 6 and 12, found that the correlation between their cognitive abilities and their academic achievement was largely driven by their shared genes.
Okay.
And this finding was reinforced for you by a 1994 adoption study by Wadsworth, which looked at 7-year-olds. Even when looking at older adults, Lichtenstein and Pedersen's 1997 research indicated that a significant portion of the correlation between intelligence and how far they went in their education was due to shared genetic factors.
This really shifts how I thought about the link between intelligence and achievement for you. It's less about the environment pushing both in the same direction and more about shared genetic blueprints influencing both.
It's a different perspective, definitely.
Now, the paper then starts to dig into the why behind these findings for you. They touch on molecular genetics and environmental factors. What are some of the key points there that we should understand?
Well, on the molecular genetics front, researchers are actively trying to pinpoint the specific genes that might be associated with cognitive abilities and academic achievement for you.
The hunt for the genes.
Right. The paper mentions some initial findings, such as a particular DNA marker linked to the IGF2R gene on chromosome 6 that seemed to account for a small portion of the differences in intelligence, and some potential links between other markers on chromosome 6 and difficulties with reading. However, it's really important for you to understand that this is still a very early stage of research.
Right, very preliminary.
Exactly. Many of these initial findings haven't been consistently replicated across different research groups.
So we haven't discovered a single intelligence gene or an achievement gene yet for you. And it's likely to be a much more complex picture with many genes interacting, right?
Exactly. It's likely a multitude of genes, each with small effects, working together in complex ways.
Okay.
On the environmental side for you, the paper discusses a shift in perspective, referencing Judith Rich Harris's work, which suggests that the long-term impact of the shared family environment, particularly after adolescence, might be more limited than we once thought.
Right, the peer group influence idea.
With peer influences and individual experiences becoming more dominant, the behavioral genetic data, with the decreasing importance of shared environment over time, seems to support this idea for you.
But the researchers also make it clear for you that the declining role of the shared family environment doesn't mean that environment as a whole becomes unimportant, does it?
Precisely. They emphasize for you that the non-shared environment, those unique experiences you have both within and outside your family, remains a critical factor throughout life and is key to understanding why siblings from the same home can have such different outcomes.
So those unique things really matter.
They really do. Researchers are using various methods to try and identify these important non-shared environmental factors for you. One approach is to look at correlations between specific environmental measures, like the number of books in your home and your outcomes. But the paper raises a crucial point about this.
Which is that many of these seemingly environmental measures might actually have a genetic component themselves for you.
Exactly. For example, the number of books in your home is likely related to your parents' own cognitive abilities and educational backgrounds, which are themselves influenced by genes.
Ah, tricky.
It is. So a simple correlation might mistakenly attribute an outcome that's partly driven by genetics to the environment. This highlights the need for you to focus more on truly non-shared environmental factors, like your individual reading habits, rather than just looking at broad family-level measures.
Things specific to the individual.
Right. The paper also mentions newer behavioral genetic approaches that use genetically sensitive designs, such as comparing differences between identical twins raised together to directly examine the impact of non-shared environment on you.
That makes perfect sense for you. If identical twins who grow up in the same home still show differences, those differences must be due to their unique individual experiences.
Or measurement error, but yes, largely unique experiences.
Now, another fascinating idea they introduce is gene-environment correlation for you. What's that all about?
Gene-environment correlation, or GE correlation, recognizes that your genes and the environments you experience aren't always separate and independent. In fact, they can be related in several interesting ways for you.
Okay.
Scar and McCartney propose 3 main types. First, there's passive GE correlation, where you inherit both your genes and a certain environment from your parents. For instance, if your parents are intellectually curious and enjoy reading, they might provide a home filled with books, creating an environment that's correlated with the cognitive abilities you've also inherited from them.
So in that case for you, the child benefits from both the genes and the environment. but they didn't actively do anything to create that environment themselves.
Right. Then there's reactive GE correlation, where the environment around you responds to your genetic makeup.
Like how people treat you.
Kind of. For example, if you show a natural talent for music, your parents might be more likely to provide you with music lessons or encourage your musical pursuits. The environment is reacting to your inherent predispositions.
And the third type for you is active GE correlation, where you actively seek out environments that are a good fit for your genetic tendencies.
Exactly. If you're a highly sociable person, you might naturally gravitate towards more social settings, or if you have a strong intellectual curiosity, you might seek out more stimulating and intellectually challenging
Like
environments.
joining the debate club or something.
Could be. In the context of academic achievement for you, a student who genuinely enjoys learning might actively look for extra reading materials or participate more enthusiastically in classroom discussions. The key takeaway for you is that your genes can actually influence the types of environments you end up in.
So it's not just nature and nurture acting independently, but nature actually shaping nurture in many ways for you.
That's a good way to put it.
They also briefly touch on gene-environment interaction. How is that different for us?
Gene-environment interaction, or GE interaction, refers to situations where the effect of an environment on an outcome depends on your specific genetic makeup. Or conversely, the effect of your genes depends on the environment you're in. It's a more complex, non-linear relationship for you.
An example.
For instance, a particular teaching method might be very effective for students with a certain genetic profile, but less so for others. While the paper mentions it, they point out that more research is still needed in this area, especially when it comes to cognitive abilities.
This whole interplay between genes and environment is clearly more intricate than I initially realized for you. Now, before we wrap up, the paper makes some really important points about what these findings mean and some crucial things to keep in mind. What are the key takeaways for us there?
One of the most important things for you to understand is that even if intelligence and achievement have significant heritability or show strong genetic correlations, it absolutely does not mean that these traits are fixed or cannot be changed.
Right, not deterministic.
Exactly. The environment, especially during your childhood and adolescence, continues to play a really vital role in shaping your development and outcomes.
That's such a crucial point for you to remember. High heritability doesn't equal destiny.
Precisely. They also emphasize for you that heritability estimates only explain the differences within a group of people, not the average level of a trait in that group or the differences between different groups.
Okay, that's a common misunderstanding.
It is. To illustrate this for you, they use the example of height. Height has a very high heritability, but the average height of people has increased significantly over time, likely due to environmental improvements in nutrition. They also mention the Flynn effect for you, the observed increase in average IQ scores across generations, despite the fact that the heritability of IQ has remained relatively stable. This clearly demonstrates that environmental factors can indeed raise overall performance levels.
So just because genes play a significant role doesn't mean that interventions or changes in our environment can't have a real and meaningful impact on our potential or our academic success for you.
Exactly right. And finally, the researchers underscore for you that behavioral genetics is a framework for understanding what is, not a tool for predicting what will be or dictating what should be.
It describes, it doesn't prescribe.
Perfectly put. It helps us understand the complex factors at play, but it doesn't set limits on what you as an individual can achieve.
Okay, this has been a truly eye-opening deep dive for you into the behavioral genetics of intelligence and achievement. So, to quickly recap the core insights for you. Genetic factors are indeed significant for both, and surprisingly, they seem to be a major driving force behind why intelligence and achievement tend to go hand in hand. The influence of the shared family environment tends to become less important as we get older, while our own unique non-shared experiences consistently matter throughout our lives. And perhaps most fascinatingly, our genes and the environments we experience are often intertwined in really interesting ways, with our genes even influencing the kinds of environments we seek out.
That's a fantastic summary for you. It really captures the key dynamics we've discussed.
So here's a final thought for you to really consider.
Yeah.
Given that the non-shared environment appears to be such a critical factor in shaping our individual differences and the gap between our potential and our actual achievements, what specific, unique experiences do you think might be the most impactful for fostering learning and development in the people around you, or even in your own life?
Yeah, that's the million-dollar question, isn't it? What are those specific E factors?
It really makes you think differently about some of our long-held beliefs about education and how we raise children.
It certainly does. And this deep dive, as much as we've covered, is really just scratching the surface. There's a wealth of fascinating research for you to explore further in the field of behavioral genetics and in the specific studies we've touched on today.
Absolutely. If you've found this discussion thought-provoking, we highly encourage you to delve deeper into the fascinating world of behavioral genetics. Thanks for joining us on this deep dive.